Okay, so before we start talking about parametric word problems, I first need to make sure you've taken the parametric equations quiz that is on Canvas. If you have not done so already, stop the video and go take the quiz. The quiz can be found in Canvas inside my class. You can click on the Modules tab. Then inside the modules, there is a parametric equations module. And in that module, there is a quiz called Parametric Equations Quiz. You need to take this quiz before watching this video. The quiz is 2 minor daily grades, so you need to make sure you do that quiz. I am going to put that in today by the end of the day. Alright? Now, let's get started on these word problems. Consider a projectile launched at a height of h feet above the ground at an angle theta degrees with the horizontal. The initial velocity v naught. Okay, you see this v with a little 0? That means v naught. Okay, it means your original velocity, your initial velocity. Is in feet per second. The path of the projectile is modeled by the pair of parametric equations. So we give you the horizontal distance in a parametric equation, and we give you the vertical distance in a parametric equation. The horizontal distance in the parametric equation is v naught, so initial velocity, times cosine of theta, so that's the angle it makes with the nearest horizontal, times t, that's your parameter. In this case, it represents time. And y is equal to h, that's your original height, plus v naught, again, that's your initial velocity, times sine theta, again, that's the angle it makes with the horizontal, times t, that's your parameter, which in this case, again, is time, minus 16t squared. All right? So we're going to use these equations all throughout these word problems. All right, let's look at problem number 1. A dart is thrown from 5 feet above the ground with an initial velocity of 58 feet per second at an angle of elevation 41 degrees. Consider the position of the dart at any time t. Neglect air resistance. So, part A says find parametric equations that model the problem situation. Okay, so that should be simple enough. I need to create 2 parametric equations that model this. Well, I know I'm using x and y that I have up here. These are my 2 models, and I just need to plug in the appropriate information. So x equals, all right, so it says v naught. Okay, that's my original velocity. So my original velocity is right here. It's 58 feet per second. So 58 cosine. And then it wants me to put in theta. Theta is the angle I make with the horizontal. In this case, at an angle of 41 degrees. So 41. And then times t, because I'm making an equation where I can plug in any time. This says here, consider the position of the dart at any time. So t. Now I need to do my verticals. That's y equals, it says h, which is my original height, which in this case tells me from 5 feet above the ground. So 5 plus, and then we look here, and it says v naught times sine theta times t. Well, v naught's my original velocity, which in this case is 58. Sine, all right. Now I need to put in my theta. Well, they give me my theta. It's 41. So 41 times my parameter t. Minus 16t raised to the second. Now you'll notice I did a little caret sign here to the second. That's because I'm typing this out. So if I was writing it out, I'd put a superscript 2 right here. Okay? So that is part A. Part B says, when will the dart hit the ground? So it's saying we've thrown the dart up. It went up. Now it's coming back down. Okay? And I need to ask, when is it going to hit the ground? So I want to know at what time t do I hit 0 again? Alright? So it's asking, hey, when is x going to equal 0 again? Alright? Well, we can actually use a calculator to do this for us. So, go ahead and pause the video and grab a calculator if you have not done so far. Haven't grabbed one yet, sorry. Alright? So, I pulled one off my screen. Now, mine is a TI-83 Plus. It'll work just fine with your TI-84s. So, we turn it on. First, we need to change our mode to being in parametric mode. So we hit this mode button. Alright, you see PAR, that means parametric. We're going to scroll down to it. We're going to click on it. Alright, so now we've got parametric. Now when you go into y equals, you'll notice x sub 1 sub t and y sub 1 sub t. So let's type in our 2 equations. 58 cosine 41. Now, we also need to stop real fast, double check our mode, make sure we're in degree mode. Nope, we're in radian mode. So we need to go change it to degree mode. Click y equals again. 58 cosine 41. It's not moving. There we go. and times t. T can be found by this button right here. All right, right underneath the word link in yellow. Click, there we go. All right, now I'm going to put in my y, so 5 plus 58. Oh, that didn't work. Oh, I need to, sorry about this, I was trying to type it, and that did not work out the way I had planned. Sine 41t minus 16t squared. Alright, so we hit graph. Okay, it looks funky. Alright, so what you want to do is let it finish graphing and then hit zoom, and then we're going to go to zoom 0 because that's zoom fit. Okay, that's going to give us something we can kind of look at a little bit better. So it's just processing. Okay, so we see right here, x becomes 0 again. Okay, and that's what we want to find. I'm sorry, I said x. We want to know when y is 0. Y represents height. Okay, my apologies there. So we can use, first we can check to see if it's a nice simple number on the table feature. So we see at time 0, I've not thrown the dart. I'm standing 5 feet up. Now I've thrown the dart at time 1. You see me go up, and I'm starting to go down. And so, okay, so somewhere between 2 and 3. Well, that doesn't give us quite exact enough of an answer. So let's use a calculator's feature. So we hit second, trace. Okay, so this seems weird. I had actually just paused my recording to help a student. And so I'm jumping back in. Alright, so we were looking here, and we're trying to figure out when will the dart hit the ground. Again, I'm sorry for the confusion. I know it seems like I was just talking, now I'm talking again. Okay, so we're looking for when will the dart hit the ground. We got to this graph, so we're looking for right here when y is 0 again. Okay, and I believe I left off saying, hey, let's let our calculator use one of these features. However, in parametric mode, these features cannot help us. Okay, so what we need to do instead is go back to graph. So we're looking at our graph here. Let's clean up our window a little bit. So first hit zoom, then hit 6. No, not 6. Sorry, don't hit zoom. Go to window. No, hit zoom 6. Hit zoom 6. That's not what I want. So hit zoom 0, and it should just repopulate this same graph again. So we'll just watch it repopulate. Here it goes. Okay, so you think that didn't help us out very much. So instead, let's go to window. So we go to window. Let's just change a few things. Let's increase we don't need to see all the negative y values, because it should make sense that I'm looking for when will the dart hit the ground. So I'm looking for when y is going to equal 0. So let's just let y equal 0. Let's look at our graph now. Let's see if that doesn't help us. Alright, so we see it go up, and we see it go straight back down. So once again, this is what we're looking at. We're looking at this right here. Well, let's try tracing it. Let's see what we get. So we trace. So I hit trace, and now I'm going to right arrow over. So I'm going to right arrow over. And again, I'm watching y. I want to know when y is 0. Or since we're approximating on a calculator, when y is as close to 0 as we're going to get. Okay, so you'll notice that y right here is a -5, so that means we're below 0 now. We're at time 2.6. And now y is above 0, we're at time 2.48. So we're just going to round this off to a nice 2.5. So we're going to say that t equals 2.5. Okay? Now it says approximate the maximum height of the dart. At what time will the dart reach maximum height? Okay, we can use our calculator to do that once again for us. So we grab our calculator. We hit trace, alright, and we're just going to trace up to the very tip top. And it looks like so when you look here, y equals 27.62, 27.39. Okay, 27.62 is our height. So approximate the maximum height of the dart. We got that y was equal to 27.62. And then it says at what time will the dart reach maximum height? So t equals, well, let's go over here and look at what t is. It tells me that t is 1.178, so I'm just going to round that to 1.18. So t equals 1.18 seconds. I should really be putting feet on all my y's and seconds on all my t's. Whoa, that's not what I wanted. There we go. How far does the dart travel in the horizontal direction? Okay, let's think about that for a second. At what point does the dart stop traveling the horizontal direction? Well, when it hit the ground again. So let's just go back to looking at it on the ground. So we're just going to hit trace again, and we're going to use right arrow to go right arrow over back to where we had it at 0.667. And how far does it seem like the dart went? 108.867. So we're just going to round that to 109. So x equals 109 feet. Alright, so that's really all you have to do. Most of this work can be done in a calculator for you.